Hi, Doc Revis here with Watch Me Work It. Percent concentrations. Let's do some mass volume percent concentration calculations. Let's start with the first problem. What is the mass volume of 5.2 mil of corn syrup in 20.5 mils of skim milk, having the densities indicated? So let's set up a mass volume. So we know if we do a mass volume percent, that's going to be the mass of the syrup divided by the total volume times 100. And so we need mass of the syrup. We notice here we have mils. So that means we're going to have to do a conversion. And if we rearrange the density formula, we know that mass equals density times the volume. And we can put these numbers in 1.48 gram per mil times the volume we have here of 5.2 mils. And if we punch this number through, we will get 7.7 grams. Alternatively, we could do this by dimensional analysis, 5.2 mils times bar mils on the bottom, grams on the top, and we use the density of that again, 1.48 gram per 1 mil, and we punch that through, we get 7.7 grams. So that means then that the mass of the syrup is 7.7 grams, divided by the volume of the syrup. We bring it down, we align it here. The volume of the syrup was 5.2 mils, plus the volume of the rest of the components. In this case, it's just skim milk as a solvent. So we have that plus that, 100. We punch this through in the calculator, and we get 30%, but the 2 sig figs. I'm going to put a decimal point to remind myself that I did it to 2 sig figs. Or I can say 30 with a bar over it to remind myself that this was done to 2 sig figs. What is the mass volume percent of a solution of 5.2 grams of corn syrup having a density of 1.48 mils gram per mil in 20.5 mils of skim milk having a density of 1.4 gram per mil? So we set up a mass volume percent will equal the mass of the syrup over the total volume. In this particular case, we have times 100 for percentage purposes, but in this case, we have 5.2 grams as the mass of the sugar, and we need the volume of the sugar. So we know that we have to do a conversion to convert the grams of sugar to mils. So let's just go to the side and do that conversion. We know that volume equals mass over density by rearranging the density formula. This is mass over density. And so our mass is 5.2 grams divided by a density of 1.48 grams per mil. And that will give us a value of 3.5 mils. Alternatively, we can do this by dimensional analysis by saying 5.2 grams times bar, grams on the bottom, mils on the top, 1 mil per every 1.48 gram. And that will give me 3.5 mils. And this value gives us the mils of the corn syrup. So now we can put that volume in here, 3.5 mils of the corn syrup plus 20.5 mils of the skim milk. They're mils of mils, so they'll add up. Can't add grams of mils, but you can add mils of mils and grams of grams. So we have grams per mil. That's what we're looking for, mass over volume, times 100 to make it into percentages. And this will give me 22%. Let's do another problem. What is the mass volume percent of a solution of 5.2 grams of corn syrup in 20.5 grams of skim milk? So in this case, we have grams and grams, but we don't have volume. So that tells us right away we're going to need to do a conversion. Well, let's just set it up first. So we'll have here mass of the syrup over the total volume again. And that volume includes the syrup plus the skim milk times 100. So what do we have here? We're doing math. So we have the 5.2 grams. And so since we have the 5.2 grams already from the problem right here, we need the volume of this. And we've done that before. In the previous problem, we discovered that 5.2 grams of syrup is 3.5 mils of syrup. So what we need now are mils of the skim milk. We have grams, so we'll need to do a conversion. And so it's a volume based on the density formula equals mass over density. And that's going to equal 20.5 grams divided by density of skim milk, 1.4 gram per mil. And if we run our calculator through on that, the 3 sig figs, we get this 14.6 mils, or we could do dimensional analysis of 20.5 gram times bar gram per mil. That's 1 mil per 1.4 gram, and we get the same value of 14.6 mils. So we'll put a 14.6 mils right here, mils plus mils, that will work, times 100 to make it into the percentage. And if we run these numbers through our calculator, we get 29%. So there you have it, mass volume percent calculations.